Okay, what is the opposite of FOIL? Say it again, Christine. Factoring, exactly. It's the other F word. Okay, so we've got FOIL, your favorite math four-letter word, but now we've got factor. It's the opposite. Okay, these two are the differences. All right, so we've got factoring. Okay, so this is the opposite of FOIL. All right, so let's compare the two. In FOIL, we are getting rid of parentheses. We do that with a series of distributing, but the whole goal of FOIL is to get rid of them. So then the opposite, if the goal in FOIL is to get rid of parentheses, the goal of factoring is to create parentheses. And they both have their advantages, so you just have to know how to do both. Okay, so those are the differences between the two. FOIL is to get rid of the parentheses, to factor is to create them. So there are a couple kinds of factoring. The first type of factoring we're going to talk about is the type of factoring called greatest common factor, or GCF. Okay, so that's that type of factoring, greatest common factor, or GCF, to find the largest thing that the terms have in common. So we'll do a couple examples of greatest common. This is not new. You've done this before. So let's start with a pretty easy one. 5x to the third minus 20x. That's called a binomial because it has two terms, like a bicycle has two wheels, and so a binomial, but each of the terms has something in common with each other. So what do these two things share? A 5. What else? An x. Is that the most they share? Okay, a 5 and an x. So what we would do with that 5 and x is we would write it outside, and then we create parentheses for what's left over. So when you take a 5 and 1x away from 5x cubed, you're left with x to the power of 2. And then you subtract, and then when you take a 5 and an x away from 20x, what are you left with? 4. How do you check your work? You would distribute it again, and that would be a quick way to check and make sure you didn't make some kind of bonehead mistake there. You just check your work. Now, this created for us something kind of unique, which is the fact that 4 is a square number. Because 4 is a square number, there's a kind of factoring called the difference of squares, where that x squared minus 4 can be separated into two more parentheses, x minus 2, x plus 2. That only works if you have a perfect square. That's called the difference of squares. So that what I just did is called the difference of squares. So difference means it has to be subtraction. Squares means the number has to be a perfect square number. So numbers like 1, 4, or 9, 16, 25, 36, 49, 64, 81, 100, perfect squares. Okay, that's what that works for. So if you ever catch one of those perfect squares hanging out in a subtraction, then you can make more parentheses. So the whole goal of factoring is to make as many parentheses as possible. So that's one example. Okay, let's try another one. All right, the next example we might have might be something like this. 2x to the third minus 8x squared plus 14x. Now this is a trinomial. There are three terms here, but all three terms do share something in common. Do you see what that is? A 2, okay, for sure. Is 2 the largest number they all share?
Yes.
Okay. All right, how about a variable? Okay, a 2 and an x. And so when I take the 2 and the x away, that leaves me with a single x squared at the beginning. It leaves me with a 4x. And then what's the last number? A 7. Now can I create more parentheses from that? Okay. There's something called star factoring or magic x factoring that maybe you learned before. Okay, so that's going to be the thing that we review next. Can you create more things from that? All right, so this was GCF factoring, greatest common factor factoring. Let's review now how to do star factoring. What did Miss Cowie and Miss Price call it? Star or magic x? Star? Okay. All right, number 2. Okay, star factoring. In star factoring, you start with a trinomial which has 3 terms, and then you create 4 terms, and that's what that star is for. So I'm going to review with you how that works. You start with a trinomial, but then you're going to create 4 terms using star. Okay, here we go. I'm going to start with a trinomial that has nothing in common. Our first trinomial is 6x squared plus 5x plus 1. Okay, it's a trinomial. Has nothing in common. Nothing in common between 6 and 5 and 1. None of the variables are in common. So this would be an appropriate time to try the star. It's more like an x, but... Okay, just got to remember where the numbers go. The bottom of the star is the center number, which is the number 5. The top of the star is the product of the first and the last term. Okay, the product. So you multiply 6 and 1, and you still get 6. The sides of the star are 2 numbers that at the same time multiply to make 6 but add to make 5. What are those numbers? Multiply to make 6, so we only have so many options, and add to make 5. 3 and 2, would it matter if you did 2 and 3? No. Okay, it does not matter. All right, those 2 numbers that we just came up with, 2 and 3, are going to become the center of my problem. So I now have 6x squared. I'm going to take 5x out altogether. I'm going to replace it with the 2 and the 3. So 2x and 3x. And then plus 1 is still part of the problem. So the star takes a trinomial and it makes it into 4 terms. You need 4 terms. The reason you need 4 terms and not 3 is because you have to split this problem in half. And it's not possible to split 3 in half evenly. That's why you need 4, so you can split it in half. So the next step of factoring is to separate this problem down the center. There should be a GCF on the front side, just between the first 2 terms. Okay, is there a GCF between those 2? What is it? Okay, so the GCF I'm going to pull out is 2x on that side only. That leaves me with what? 3x plus, not nothing, it's never nothing, plus 1. On the left side, there's a GCF also. Now you might disagree with me at first. You might say, well, 3 and 1 have nothing in common. Okay, sure they do. Everything always has a 1 in common, at least. you have to pull out something. You have to find a GCF. The GCF is the number 1. In fact, it's a positive 1. And what's left there is 3x plus 1. And if you have done the process correctly, you'll notice that on both sides of the yellow line are the same parentheses. So the purpose of factoring is to create parentheses, and we've just created identical parentheses. So that is going to be the first parenthesis that you answer is 3x plus 1. If you take that 3x plus 1 away from both sides and look at just what's left, that'll be your second parenthesis. Okay, so if I took 3x plus 1 away, oops, didn't mean to erase that one, and if I took 3x plus 1 away from this side and I just looked at what was left, 2x on that side, 1 on the other, that's the other parenthesis, the answer is 2x plus 1, and there's your answer. How would you check your work?
Foil.
You'd foil it back again, and hopefully you end up with what you started with. Because you came, yes, okay, great. Well, hopefully it will make sense. Okay, here we go. Let's try that. Let's try another one. 9x squared minus 12x plus 4. Okay, it's a trinomial that has nothing in common. Now, if it had something in common, we would take it out. But right now, the trinomial has nothing in common, which means this is a great time to use your star strategy. Okay, in the star, the bottom is going to be what number? Which is negative 12. The top would be what number? 36. Okay, so now we just got to think of all the ways to make 36. What two numbers could I use to do it that would also give me negative 12 if I added them up? Perfect. Negative 6, negative 6. So I'm going to cross out my center number here, and I've now gone for 9x squared, and I take the first minus 6, and it becomes minus 6x. I take the second minus 6. So remember, the purpose of the star is to give you 4 terms. Why? Because you can't split 3 terms in half. You need 4 so that you can, it's an even number, so you can split them in half. So I'm going to separate them into a front side and a back side. Both sides should have a GCF that you can find. Sydney, do you want to try it? Or maybe Carter, since you said this was the first time. Okay, so let's try it. Yeah. So I'll let you do one side, and maybe Sydney can do the other one. All right? All right, what do they have in common? What do 9 and 6 have in common? Okay, they have a 3 and they have an x. So on that side, what's left over? 3x minus 2. Okay, Sydney, how about the other side? Between the 6 and the 4, what do they have? Okay, now here's a tip. If the middle term is negative, like that negative 6 is negative, then whatever you say you're going to take out should be negative also. Okay, so we're going to take a negative 2 out. When we take a negative 2 away from a negative 6x, we're left with positive 3x. We're also going to take a negative 2 away from the 4, which also leaves me with negative 2. Why is that important? It has to match the other side. Okay, if we only took, let's imagine what would happen. If we only took a positive 2x away, then we would be left with a negative 3x plus 2, which doesn't match the other side. They've got to be identical factors on the other side. So that's why it's important to take a negative, if you have the chance, out. And so then I recognize, yay, they match. And so my answer is 3x minus 2 for the matching factor. And you don't have to erase it, but sometimes I do to help me out. Okay, I'm going to erase 3x minus 2 on both sides and look at what's left. And what's left is actually another 3x minus 2. Okay, so you have identical factors left. And you could check your work by foiling them out. Yeah?
Isn't there an easier way to do that?
Tell me.
This is the way that I was taught.
Okay.
You draw another line in your star,
Mhm.
and you're at that step,
Mhm.
and then the 9 goes goes at the top
Mhm.
of that second spot,
Mhm.
and your answers go on the bottom.
Mhm.
And then you put in parentheses, it's those two slots, so it would be 9x minus 6,
Mhm.
and you put those in parentheses, and since it's 9x minus 6 on the other side, you do the same with those,
Mhm.
and you just factor them down, you don't have to take anything out of it.
Yeah, so you have to remember to reduce is the
Reduce.
key there. Yeah, the reduce. And that will totally work, okay? And so if that works for you, that's fine. Okay, the reason I like this is because this is going to work on all future problems, and we don't have to learn one way that works in this case and another way that works in this case, and this is just one way that's going to work for all of them, for all the ones we're going to do in the future. So yes, that one works on numbers that we're doing today. Okay, when we move on, it's not going to work anymore.
Okay.
So for me personally, I'd rather learn one way that covers everything rather than a different way. Yes, it might be easier in the short term, but in the long term, you're going to have to learn more of them, more strategies. So it's up to you.
Why is that one not working the future way?
Because when I give you, which was coming up in my notes, you're just jumping the gun a little bit here. When I give you this, where there's already 4 terms, star doesn't work anymore.
Okay.
So now you need to learn what to do with that.
Alright.
Because star only works in the case where you start with 3. So what if you start with 4? Or what if you start with 5? Or what if you start with 6? Then what do you do?
Alright, that makes sense.
Okay, all right, yeah, Micah.
So, I have a different way of doing it. I talked to Miss Price about it.
Okay.
She was too proud to let me tell her. So it's like, every time the star method works, it works similar to the star method,
Mhm.
better.
Okay,
You want me to explain it to you?
sure.
Okay, so give me an example.
Okay, let me pause. All right, so here's your 4, right? So you take your 4,
I think you have to
split it down the center. What can I pull out from that side? What do they have in common?
I mean,
What's the largest thing they have in common? More than just x.
Oh, yeah.
Oh, I didn't see the 4, sorry.
X to the 4th is the largest they have in common. Which leaves me with, if I took 4 x's away from 6 x's, how many am I left with? 2, x squared. And then minus 3. Okay, what does the other side have in common? A 1. Okay, don't say nothing. You have to take something, even if it's just a 1, leaving me with x squared minus 3. So I have the 2 same common terms on both sides. And if I take those both away, what I'm left with is x to the 4th plus 1. And now I'm factored. And I created parentheses. And it worked on 4 terms. Okay, we'll get to 5 and 6 other days. We're not going to get anything more than 4 right now. So yes, as in math, there's lots and lots of different ways to solve things. You can learn shortcuts. The problem with shortcuts is they usually only work on certain cases, and then you run into a problem where they don't work anymore. Okay, last one. What do you do if it already partially has some parentheses in it? So something like this, 5x with parentheses x minus 2, and then minus 3 with another parentheses x minus 2. The splitting method, the split factoring method, splitting it right down the center, still works. Okay. What do the 2 sides have in common with each other? They both have an x minus 2. If I take the x minus 2, which is the common factor, away, and look at what I'm left with, all I'm left with is 5x minus 3, and that's the answer. I created parentheses. Okay, so it works in lots of different situations. Okay? So if you have something, if you want to do a different one, that is fine. Just know when you can and can't use it. Okay? Because then if you use it in the right way, great. But then if you use it the wrong time, then no bueno.